Hi, my name is Professor Ellery. I'm a Canada Research Chair in Space Robotics and Space Technology. This is my lab and this is my group, the Space Exploration Engineering Group, which I lead. And our job is to essentially develop new robotic techniques to enhance space exploration. The work we do in my lab is essentially there are several things we do which are associated with traditional robotics. For example, manipulator control in space in order to develop new techniques to fix satellites when they go wrong in space. Secondly, our work is based on planetary rovers, develop new rover techniques to make them more efficient robots to explore other planets. And I also work on developing new AI techniques to make satellites smarter so they can resist against things like cyber attack. However, the latest work that we do, I think, is the most interesting aspect, and we've been looking at how to use 3D printing on the lunar environment and on other planetary environments. A few years ago I asked myself the question, what can space exploration or space technology do to help solve some of our global problems such as climate change? And one of the things I came up with was the idea of implementing solar power satellites as a form of clean energy. Now, of course, this is an old idea, it's not new at all, but one of the big hindrances to it has been the sheer expense of actually launching these large satellites or large constellations of satellites into Earth orbit to capture solar energy and then beam it down as microwave to the Earth. And of course, the cost element has always been the launch. So one way to circumvent this is to forget launch entirely and actually try and build these satellites actually from material that's available in space, such as the Moon. And this is one of the things we've been working towards. The next stage is to take that raw material and then somehow manufacture useful products like spacecraft, robots, that sort of thing. If we can 3D print electric motors and 3D print computing electronics from lunar material, it basically means we can print robots. If we can print robots, we can print any type of kinematic mechanism or machine. If we can do that, we can then print the components for a solar power satellite. And if we can print the components for a solar power satellite, we can build a solar power satellite on the Moon and then send it to orbit around the Earth and then provide a form of very low cost, cheap energy supplied to the Earth. Yeah, if we can build, the end goal is to build a self-replicating machine. Now, a self-replicating machine, essentially, you can imagine it as a 3D printer on wheels, a little bit more exotic than that perhaps, but essentially you can take in raw materials and build copies of itself. The power of such a machine is immense because it means we can build, say, a general purpose factory. We can then build a copy of that general purpose factory and then keep on building, exponentially increasing that population, generating a productive capacity which grows exponentially. Although we're initially applying this to the Moon, it does have applications on Earth. And one particular example, of course, is, for example, greening of the Sahara Desert, which would be very expensive to do, but with a self-replicating machine it becomes actually very inexpensive and actually becomes quite plausible. It has implications also in developing countries because the unit itself is very small. It could be a form of providing productive capacity, local productive capacity in developing countries, for example, at very low cost. And because it's 3D printing, it effectively costs nothing.